Choosing the best method. We have come to the point in our unit where we can just look at our buffet of options and just talk about it for a second. We have graphing and tables, which are both good for when you have equations like this in y equals form. Then we have situations where you might have one equation like that, but the other one is in what's called standard form. And you have to use substitution to substitute in what y is on the right for y and then solve. And then finally, if you have two equations in a row that are in standard form, that's my standard form voice, by the way, then you could use elimination for these two. We have done this now. We can figure out for this assignment, if we're just given a problem at random, which method do we use and why? Number 1 says 4x plus 3y is negative 29, and negative 4x plus y is 33. We could see the x's are above each other, the y's are above each other, and the numbers are above each other. This is a situation of what we just did on our last assignment. We know that it's elimination. Why? Because our x's or y terms are opposites, as in our x's are lined up, our y's are lined up, and our numbers are lined up, and it's all in standard form. Number 2, I see that my bottom equation is in standard form, but my top equation is solved for x. That means we need to use substitution and plug in x into this equation down here. And that is because formally x or y, in this case x, is already isolated. Well, using our test-taking skills, we've done elimination. We've done substitution. That must mean the last one is going to be in y. Yep, a couple of y equals mx plus b form, just like this green one up here. Graphing or tables would also work because they are in slope-intercept form, y equals mx plus b. Okay, then very simply, we're just going to do one problem from each type, starting with the easiest one, graphing. So I've got y equals negative 3x plus 13, and y equals negative x plus 7. I can see these graphs. Well, I can't really see. Oh, there they are. Zoom out. They touch at 3, 4. Easy peasy. Once my internet loads, it should confirm it. There we go. Easy, easy, easy. Number 5 is another one that they're both in y equals form. If I had my graphing calculator, I would be more likely to recommend tables, but because the table function on this Desmos calculator is, you have to manually type in them all, let's just do graphing. And these cross here. Oh, I mistyped something. Oh, that's supposed to be 9. And that's supposed to be 2. It's getting late in the day, I guess. I should probably quit after this. Negative 3, 8. I'm slipping. I filmed too many videos today, I guess. By the way, hello in the future. I hope it's looking good. Much better than when I filmed this in the middle of the coronavirus pandemic. Number 6. These are a couple of equations that are in standard form. Therefore, we need to do elimination to solve them. So let's just do this. I haven't done this yet. I'm going to line them up, leave them there. Notice how my y's cancel. And my x's, negative 1x, I could just put a 1 there. Negative 1x and negative 5x is negative 6x. And that equals negative 7 minus 29 is negative 36. Then I do my little sad me rabbit division. What a weird sentence. X is 6. So I know it's going to be 6 comma something. I got to plug that back in. Oh, I hate all these negatives, but it's simpler up here. The numbers are lower, so... Actually, no, because y is positive. Yeah, let's do this one. So negative 5, x is 6, plus y is negative 29. I'm just copying this equation down here. Negative 5 and 6 make negative 30, plus y is negative 29. Now I can just add 30 to each side. Don't know why my 9s all are not looking good, but there you go. Negative 29 plus 30 is 1. Let's check it real quick. Negative 6 minus 1 is negative 7, and negative 30 plus 1 is negative 29. Perfect. 6, comma 1. Little elimination. And finally, I assume we're going to do a substitution problem. Indeed we are. So I'm going to rewrite the standard form equation, but x is y minus 7, so instead of x, I'm going to write parentheses y minus 7 plus 6y equals negative 8. Then I use my distributive property, little rainbow. 4 times y is 4y. And then in blue, 4 times negative 7 is negative 28. Plus 6y, that's a plus there, is negative 8. So 4y and 6y, that's terrible. 6y make 10y minus 28 is equal to negative 8. We add 20 to both sides. Do a little sad me. 10y is, it says 28. Wow, those 8s are not showing up. There you go. 20 divided by 10. Y is 2. And the good thing about substitution is the second one's much easier to solve than the first, because we know that x is y minus 7. Well, if y is 2, then 2 minus 7 is negative 5. So then x is simply just negative 5. Again, let's check. Well, we should definitely have this first one be right. We judged everything on it. 2 minus 7 is negative 5. Yeah, but what about this one? In fact, let me just show you. Negative 5, 2 is what we think it is. I like this. Negative 5, 2. So I'm going to plug into standard form and see if this works out. I'm going to use this 4x plus 6y equals negative 8 equation, where x is negative 5 and y is 2. So the question is 4 times our x of negative 5 plus 6 times y of 2. Do we get negative 8? Yes, we do. So we know, since our equations check out, even without using our graphing calculator, just the regular little numbers there, that we're right. And we do feel like a superstar. All right. Very efficient summary of graphing and substitution and elimination. Just a quick little 7.5 minute assignment. This whole video will be less than 9 minutes. Well done on this whole unit. These can be tedious. Hopefully you're writing these out. But also maybe you've got some confidence now and feel good about one or multiple of these methods, even if it's just graphing. Take care. Until next time, it's always an honor and a pleasure being your teacher. Bye-bye.